so I'm looking at F1 now. So F1, the magnitude is 200 pounds represents the magnitude, is that correct? So we have my magnitude represented at the beginning with the numerical value and at the end with the units. And then inside, this represents a vector, right? A vector has magnitude and direction. So this middle part right here represents my what? My direction. So first step, I represent the force on the left, put the units on the right. Here I put in what my distances are. This is my ratio part. And then step 2 is representing the force with its magnitude and its unit vector. Notice in engineering, we represent unit vector in 4 decimal places. In math, I believe we use fractions. We don't use fractions too much, and we definitely, as engineers, never use fractions with radicals in it. As we go along, why don't we take a look at this kind of rule sheet, the summary sheet. I'm going to put this up here as we go along. So if you look at rules for unit vectors, you always represent it in 4 decimal places. Okay? So step 2 represented the magnitude with the unit vector. Step 3 now represents the x, y, and z components of the force. How many decimal places do I have? 1 decimal place. So for forces, we always use 1 decimal place more than the given force. And the given force was 200 pounds, so we're representing it with 1 decimal place. In step 3, how am I representing my force here? Up above, I represented it with magnitude and unit vector. What's this? Vector form, or Cartesian vector form. So let's take a look at this summary sheet. Representing vectors, vector form, we showed that. And magnitude and unit vector, we showed that as well. If you space out at any time while I'm talking, you just raise your hand and say, I just spaced out, could you repeat that? Do we have an agreement on that?
Yep.
Okay, everybody with me? So now I have to do my checks, right? What are the checks I'm going to do? Take a look at the summary sheet. The first check is a positive, negative visual check. So I did that here. I took a look at this and I noticed that my x component of the force was positive, the y component was positive, the z component was negative. I go back to the picture and yes, it should be positive, positive, negative. So my visual check is good and I have to write it down. If you want partial credit on anything, you have to show me all the work. You need to show me all this in the 3-step process. You need to show me the checks. And make sure that you check them. Don't just write they check. Because if you didn't check them and they don't check, you're in the doghouse. And I did that actually when I was doing this problem. I went, okay. And then I said, wait a second. And I had an error. Okay. The other thing we want to do is represent vectors in magnitude and direction angle. And somebody realized for me that this was actually for F2. And here's F1 down here. So F1, I solve for theta x, and theta x are the direction angles, and we'll talk a little bit more about that with the PVC pipe in a little bit. It's the inverse cosine of my unit vectors, and I found the values. Thank you. And then I also want to do a check there. So we did a positive, negative visual check. I did a force check. I looked at all the forces. And I found that they did check to 200, and I did a unit vector check. So I did all the checks. So here what I'm doing, I'm finding out what the direction angles are. So I could also represent F1 as equal to 200 pounds, which is, what does the 200 pounds represent? It's magnitude. X1 is 71.7 degrees. Delta Y1 is equal to 35.8 degrees. Delta Z1 is equal to 119.1 degree. So now I'm representing it as a magnitude and direction angle. So I'm going to check that off. Okay. So on the sheet of solutions that I gave you, and this again should be reviewed because you worked on this during the break, but for those of you that didn't or didn't get the email, The point is that you have now until Tuesday to until next Tuesday to make sure that you are up on this stuff. As we go over the syllabus, you'll see Evan, that's Evan, he's our TA. Evan's being our TA. So Evan and I are going to run workshops up in the STEM Center, and that's why I pulled you on the purple page to see when you're available, okay? So we're going to be around a lot to help you. You want to make sure that you stay up on the class, don't get behind. Who is a civil engineering major? What do you think the most important class you take at Cabrillo before you transfer is?
This one.
This one.
Surveying.
This one, statics. What's second most important? Graphics for civil engineers. Third most important? Surveying. What's the first most important civil class?
Statics.
This one. Who's mechanical or aero or mechatronics? Guess what the most important class that you take is?
Dynamics.
This one. Second most important, the graphics, because you need to know AutoCAD and the Pro-E, and then the third most important is materials. What's the most important class?
This one.
Statics. Okay, chemical engineering majors. Most important class you take? Chemistry. And if you go towards the materials industry, then the materials class is the most important. What other majors are there? Industrial, bio. Anybody interested in bioengineering? Biomedical. Okay, so biomedical. If you want to go biomedical where you design mechanical devices, statics would be the most important. And the next would be materials. What other majors?
Maybe electrical.
Electricals, this class isn't required. So you, yeah, but usually you'll have an if you're going towards biomedical, you'll have an electrical engineer on staff as well. Okay, so what's the most important class you're taking?
This one.
Materials or chemistry, yeah.
Aside from the chemistry, chemical engineering, this one. Sometimes you guys put more emphasis into your physics class because it's 5 units, and the math class because it's 5 units, but it's bullshit because physics and math should not be 5-unit classes, they should be 3 or 4. You're getting a 1-for-1 units for this. This course takes just as much time as the physics and the math class. Okay, it's just I'm giving you the units that you would get at a university. They're having you be in class more time. Make sure you do well in this class. It's the foundation for everything you do. Dan?
How many statics classes are there? There's more around the university?
Then you have a dynamic. We'll talk.
Okay.
Okay. All right. Let's go back to this. So how do I check off direction angles? Here it is up here. It's a Pythagorean theorem, really. Again, cosine squared of theta x, cosine squared of theta y, cosine squared of theta z, and it should give me 1. And then, for those of you who remember from the video, how can I check the magnitudes of these, whether they're acute or obtuse? I'm noticing that theta x and theta y are acute. What does that mean about the direction of the force? They're positive. They're positive. If you're getting a theta angle that is obtuse, what does that mean?
Negative.
The value is a negative. So let's talk about theta x, theta y, and theta z. So they're all direction angles. So first important thing on a 3D problem is to look at the axes. What axis do you have sticking out at you? Take a look. Z. So I need to give you z. What do you have to the right? X. Okay, right? Z's towards you, X is to the right, Y is going up. So where is this force? This force is going back here, isn't it? Everybody check me?
Yeah.
Move this down a little bit. And we learned from the videos, and those of you that came from the workshop, that the theta angles, the direction angles, are what? What angle do they represent?
Angle between the positive axis you're looking at.
The angle between the force in question and the positive axis. So for theta z, for the z-axis, this is theta z. And you'll also remember from the workshop or from the video that this is probably the only time in your life that one variable could have two values. A theta z is this value, or you could go around the other way. So what about theta x? Where's my theta x here? It's the shortest angle between the force and the x-axis. And here's my theta y. So does it make sense that if this force is in this octant back here, it should have an acute x and acute y? Does that make sense? Because they're both positive values. But because the force is going in the negative z direction, I should have an obtuse angle for my theta z. Everybody good? Again, if you did not get the emails, you might be like, kind of confused right now. Well, then you got to come see me or Evan, because I want to make sure that everybody's comfortable. So I represented the force three ways. What are the three ways? Vector form, magnitude n, unit vector n, magnitude and direction angles. And then I have all the checks here, right? And I'm looking at some of the rules already. So for forces, we use 1 decimal place more than the given force. For unit vectors, we use 4 decimal places. And for angles, we noticed here with the angles, we always report it as 1 decimal place. Okay? And always show units. So whenever you have an equal sign here, always show the units. Okay? All right, let's go to F2 now. 3D or 2D? Ratio or angle problem? Angle problem. So what theta angle is given for F2? So let's look at this picture here. Looking at the picture, which of the three theta angles are actually given? Or you can calculate. Just the y. So let's set this up in 3D space again. So z is coming at you, right? Where is this force? I'm covering up so none of us can see it. Okay, Rachel, again, I have to stop eating this food. Making me very hungry and my stomach's gonna start hurting. Okay, so it looks like it's right here, right? If they're quiet, I can't tell, but it's crunching. That's okay. Okay, is this where it is? Right? Okay, so now what are we looking at? For theta z, this is my theta z angle, right? My direction angle, it should be the shortest angle from here to here. Where's my theta z? I'm sorry, y. It's this angle, right? And how about my theta x? It's from here all the way over here, right? It should be obtuse. So looking at the 30 degrees and the 40 degrees, only one of them helps you find one theta angle. Which one is that?
30.
The 30 degrees, because the 30 degrees is going from the force to the xz plane. So that means the angle going from the force up to the y is going to be what? 60 degrees. So this right here is 60 degrees. And what's that mean? What does 60 degrees represent? Theta y. Because it's the angle between the force in question and the positive y-axis. So, do we have a theta x or a theta z given here? No, they're not giving it to you. What they're only giving you is the angle between this force and the projection down on that xz plane, and then they're giving you the angle between that projection you just found and the z-axis. Okay? So when we try to find, we're here, F2. When we're trying to find the y component of f, no problem. I'm using the cosine of 60. And in a little bit, we'll talk about why we use cosine in engineering more so than using sine. But in finding the x and the y component, I have to flip them. So from the videos and the workshop, we learned that if I know, let's just do z for a minute. If I know what theta z is, I take the force, the magnitude of the force, and I multiply it by the cosine of that direction angle, and then I find the component of this force in that direction. Got it? I take the magnitude of this force, I multiply it by the cosine of theta x, and I find the component of this force in this direction. So in this case, there's only one theta given, x, y, or z. Which one? The y. So if I take this force and I multiply it by the cosine of, what was theta's y? 60. Take this magnitude of this force, multiply it by cosine of 60, I'm going to get the magnitude of that force in the y direction. But in the other two, I don't know what theta x and theta z are. So I have to do it, I have to get there in 2 steps. If I take the force and I multiply it by the cosine of 30, it brings it down to the xz plane. And then I multiply it by the cosine, what was that value? 40, and it brings it over to z. So it's a 2-step process. If I know what the theta angle is, the direction angle, I take the force and I multiply it by the cosine of that angle. But if I don't know it, then I have to do it in a 2-step process. I take the magnitude of this force, multiply it by the cosine to here, and then the cosine to here, and then I get it into z. So in this case, we're looking at F2, again, 3-step process. It's a 3D angle problem, so we're not using ratios, we're using angles. I put the magnitude, the number 300 here, pounds here, and then I have to multiply it by cosine of 30, cosine, oh, thank you, let's zoom out a little bit. How's that? So the cosine of 30 brings it down to here. And then I multiply it by the cosine of 40 plus 90, and I bring it to the x-axis. So 300 times cosine 30 times cosine 130 is going to give me the x component of force. Then, y component, we know theta y is 60, and then here, I'm trying to find the z component. I take the magnitude of the force, multiply it by the cosine of 30, and now cosine of 40 because it brings it to my z. First step, I use angles. Second step, what do? This is magnitude and unit vector, and then I do the unit vector check. Third step, what's third step? Vector form, or Cartesian vector form, and I do a magnitude check for the force. And then I do a visual, plus or minus visual check. What did I get? I got a negative on the x, so go back to the picture. Should I get a negative for the x? Yes. And I should get positives for the y and the z, and I did. So I did a positive visual check. Yeah, Santiago.
Joanne, I noticed that when you were trying to find or calculate the angle.
Right, so now we're
to
going
the
up to
x,
here. This one?
No, sorry, the second one, when you're using angles,
Oh.
you're bringing the force down to the xz plane,
Correct.
and then you went counterclockwise to the x-axis.
I could have
you
went the other way.
Okay.
Yeah. So when I wanted to find, here's Santiago's question, if I want to find the force in the x, I could say 300 times cosine 30 times, I could go the other way, which would be 80 plus 40, which would be 220. Either one works. They both work because the code will talk about why cosine works in a little bit. Okay? And then I solve for my angles. I solved for my direction angle, theta x, theta y, and theta z, and then I did a check for that. Okay, turn to the person next to you and just talk about what things are confusing for you, or do you have this all down, or what?
Is anything confusing for you?
So,